Hi, I'm an old guy and I do maths, and what we're going to look at today is how we differentiate e to the x. Um, and this could be over in a flash because the differential of e to the x is e to the x. Um, can it really be that simple? Well, in this precise case, yes, it can. But there's more to it than that. There's a great deal more to it than that. And if you don't understand what's going on, yes, you'll be able to differentiate e to the x, but good luck with everything else. So let's have a look at what really happened. Um, function of x equals e to the x with a constant here. Now, if I were to put that constant here, what I would wind up with for my differential is this. And you can see why, in this case, e to the x would differentiate to e to the x. But where k is something other than 1, we get a different answer. And how we do this is we use the chain rule. So let's get into this. So I've done a video on the chain rule. You can look it up and have a look at how it works if this is unfamiliar to you. The thing to realize here is that we're going to make this expression here the constant, which should be a number, but it can be a letter. There's nothing to prevent it from being a letter, but it's usually a number. This we are going to make equal to u. We're going to call this u for our purposes. And what the chain rule does is it basically splits up our problem. It's made for cases like this where you have what could otherwise be a very difficult piece of work to differentiate. So, for example, you could have you'd use the chain rule for something like this. You don't want to expand that, and again, in this case, we have to assign u to this, and then we go ahead and differentiate. So let's see what goes on here. So effectively, the differential of e to the kx is the differential dy du times du dx. And if we name kx, this here, if we name it u, we can go ahead and differentiate. Okay, so what we wind up with is e to the u times k. The differential of this is k. The differential of u is k. Du dx in this case is k. If this were 2x, the differential would be 2. So the rule becomes the differential of x when x is equal to e to the x is k, the constant, times e to the kx. That's the rule. I hope this is clear. There will be examples in the playlist of differentials of e which involve more complications, and strangely enough, when you see those complications worked through, it becomes easier to understand what's going on. But basically the rule is that if your function of x is e to the kx, even if k is 1, the differential is k times e to the kx. Thanks very much for watching. See you next time.